Hello everyone, welcome back to Tutor Corner LLC, and today we will be covering the power of a power. So this is an exponential rule dealing with powers. So let's go on ahead and jump right into it. So the format for this, or at least one of the formats, is you typically have some sort of number or variable inside parentheses. And outside of the parentheses, you have some sort of power, let's say A. In this case, whatever is inside the parentheses, will be raised to that power, okay? So in this case, it'll just be x to the power of A. Okay, another way that this could be shown is x to the power of A already inside the parentheses, and outside the parentheses is to the power of B. In this case, everything inside the parentheses will be raised to this power. Now, if you think about it, this x or variable right here, or base, is already being raised to A. Now, we're going to raise this set to this. So how does that look like? Well, what you will get is x to the power of A times B, or x to the power of AB. Okay, so that is how it applies in a scenario where there's already a power inside the parentheses. Let's do a more complex one so that we can better understand what is happening here and better apply it to more complex mathematical problems. So let's say we have x to the power of A, y to the power of B, and z has no power, or just to the power of 1. All of that inside the parentheses to the power of c. So in this case, the way that we will try to do this is we will break down each variable inside the parentheses, or each base. First one's right here, second one is right here, and third one is right here. So here is what we will do. Every single one of these, this, and this, is being raised to the power of c. So let's start with the x to the power of A. X already has a power, so it'll be x to the power of A times the power outside the parentheses, or c. Okay, and we are done with x for now, and the variable y, as you can see, y is being raised to b. Then we rewrite y to the b, and it's being raised to c outside the parentheses, so we multiply that b with c. Last but not least, this z right here is not being raised to a power, so we'll just write z right here, and as you can see, it has no power, so we'll just raise it to the exponent outside of the parentheses, so it'll just be to the power of c. Now, when you reduce this, you should get something like x, a times c, it's just ac, y, b times c is just bc, and z to the power of c. And that is the final simplification for that. Okay, with positive exponents, assuming that a, b, and c are positive. Okay, so let's go on ahead and jump to some examples. Remember, you're more than welcome to pause this video if you would like. So let's jump on back to the example. Example 1. Okay, so example 1, let's say you have 4x inside the parentheses, and the power outside the parentheses is 2. In this case, these will be separated. The 4 is a separate entity, and the x is also separate. So we will start with the 4. As you can see with the 4 doesn't have any powers. So we'll just rewrite 4 to that power outside the parentheses, which is 2. And we're done with that 4. And this x has no power either. So we will just write that x to the power of whatever's outside the parentheses, which is 2. And that's all we've got here. I think it's a pretty basic example. So 4 to the power of 2, that's just 4 times 4, or 16. x to the power 2 will just be x to the power 2, and hence this is our final answer. Okay? Example 2. All right, example 2, let's add a little bit more info in there. So 3x to the power of 2 inside the parentheses, and the parentheses has a power of 3. Okay, so remember, you're more than welcome to pause this video if you'd like to try to go over this by yourself, and you can always unpause it once you're ready to go over it in this tutorial. Okay, let's do it. So that is equal to, let's separate the numbers or variables inside the parentheses. We have 3, and we have x to the power of 2. By the way, this is called power of a power because you see how there's a 2 right here. There's already a power to the x, and it's being powered again by 3, and that's why it's called a power of a power. Okay, so 3, we'll rewrite 3, that's being raised to the power of the outside, or 3. We're done with that. We move on to x. We rewrite x squared, and x squared is being power, or is being raised to the power of the outside as well, which is 3. Okay, so let's simplify it. 3 cubed, 3 times 3 times 3, which is another way of calculating it, is 27. X just remains itself, and 2 times 3 to the power of x, for the power of the variable x, I should say, is 6. Therefore, our answer is 27x to the power of 6. Remember, if you have any questions, don't forget to leave a comment in the comment section below. Example 3. Let's add a little bit more. Example 3. Let's have something like 2x for y all to the power of 4. If you'd like to pause this video to work on it by yourself, you're more than welcome to do it. And you can unpause once you are ready to see how to do it. Okay, so let's do this one. Let's separate what's inside the parentheses. We have a 2, which has no power, x, which has the power of 4. Last but not least is a y without a power. So let's do these. Let's compute this one by one. Okay, so 2 has no power. We'll just write 2, and the outside power is 4, so 2 to the 4, and then we will write the x to the 4. This is the x to the 4 to the power of 4, so you multiply that power already existing by 4 outside the power of the parentheses. Okay. And last but not least, y, which has no power inside the parentheses, and it'll be raised to the power outside the parentheses, or 4. So this is what we have. Now when we simplify it, we get 2 to the power of 4. It's just 2 times 2 times 2 times 2, and that should render 16. X is just rewritten. 4 times 4, that is 16. And then y to the power of 4 is already simplified. Therefore, our answer for this one is 16x to the power of 16, y to the power of 4. All right, hopefully you found this video helpful, and like and subscribe for more. If you have any comments or questions regarding anything in this video, please don't hesitate to leave a comment. Remember, like, share, and subscribe for more. Thank you.